Okay, kiddos, now we are wrapping up Unit 10. So this is the last day. We're going to talk about segment relationships in circles. So we remember segments are lines that have one end point and then they have another end point. Okay, so we're going to talk about chords and then secants and tangents, okay, and how they are related in a circle. So let's get right into it. So what we're going to see is we're going to see three different varieties. We can see something like this, where they intersect inside the circle, right? And then these two where they intersect outside the circle, right? They intersect this one and this one crosses right here, right? This one and this one crosses right here. So depending on where the intersection is, we're going to have a different rule. So let's go through those. So first off, if it's inside the circle, right? So if it meets right over there, so we would say the intersection is inside. Okay, this is the rule that we're going to use. Okay, so we would say what we're going to do is we're going to think of it as two different chords, right? This one, I'm just going to color those differently, and that one right there. Okay, so if we see over here, here's the relationships. DE times EB, right? That means multiply, and it might be better to do it like that. DE times EB. So DE times EB. So on this purple one, we could say that this is part number 1, right? And we'd say this is part number 2, right? So two different parts, right? And then this blue one, we could say those are two different parts, right? AE or EA would be one part. Actually, let me do it over here. We could say this is part 1, right? And then this one would be part number 2. Okay, so here's the rule. DE times EB. So this part, right, times this part is going to be equal to this part times this part. Okay, so that's what the rule is. So we would say the rule is going to be part 1 times part 2 equals, I'm going to put number 1 and number 2, equals part number 1 times part number 2. Okay, so we'll get more into that in some practice, but that's what we're going to say. Part 1 times part 2 equals part 1 times part 2. Okay, so that's when they intersect inside the circle. All right, next we're going to talk about if they intersect outside the circle, right? So we said these two lines intersect right over here, right? And then this and this intersects right over there, right? This is just showing a radius, right? That it has to be, because it's a tangent, we have to have a right angle, right? Remember we talked about. All right, so the intersection on both of these are outside. Okay, so that's the difference. Now, as you see, this has the same heading. They're going to be the same rule. It just looks a little different, right? So on this one, we're going to say, okay, so say that this is one, right? And this is the other one. All right, so now when it's outside, we're going to think of two different ways. We're going to think of this part, which is the outside, right? And then we're going to think of it like this, which is the whole thing. Okay, and then same thing on this one. We're going to say this one is the outside. And then from H to D is the whole thing, right? So we'd say this to there is the whole. Okay, so we're just going to separate those parts. So here's what we're going to do. We're going to say GD times SD. So that means the outside times SD is the whole thing. So we're going to say the rule is outside times the whole is going to be equal to JD times HD. So JD is the outside and HD is the whole as well. So we're going to say outside times whole equals outside times whole. Okay, outside times whole equals outside times whole when it's on the outside. Okay, same thing on this one. Let's look at this. This one says CD times CD. Well, if we think about it, this part right here is the outside, but it's also the whole, right? It's also the whole thing on this because it's only one part, right? Now on this one, we would say that CB is the outside, right? And then we would say C to A is the whole. Whole, right? So that's our rule. We're going to say the same thing. Outside times the whole equals outside times the whole of the other one. Okay, so let's look at it right over here. We said CD times CD, so that's the outside of this one, right? Outside the circle times the whole thing is still the same thing, right? CD, CD equals this one. The outside is BC times the whole thing is AC. All right, so I know that sounds kind of tricky, but we'll just keep that in mind and we'll get right into some practice. All right, so let's do it. All right, next, first, we're going to talk about, we said, intersecting chords, which is right over here, inside the circle. So we said the rule was part times part equals part times part. So let's get right into this. It says, given the circle below with chords AB, right, and CD, those mean they end on the circle, right? Find the length of AE. So let's underline that. That's what we're trying to find, right? Find the length of AE. And let's kind of just scribble that so we know, right? And what do we label for something we don't know yet? We're going to label that with the X, right? So the first step we want to do is we want to label. Okay. Second step is we want to set up and then solve. Okay. So let's look at what we said. We said part times part equals part times part when it's on the inside, right? So this is the inside. Okay. So we're going to say part times part equals part times part. Okay, so let's fill that in. So the first part would be X, right? This on this one. So let me highlight that. The first part would be X. The second part would be that 10, right? So I'd say 10 times X, right, equals this part times this part, right? So if I say this one right here, let me go and highlight that a different color, right? So the first part would be 11. Second part would be 20, right? Because this part is 11, that part's 20. Okay, so once we set it up correctly, that's all we have to do is just do the math. Okay, so next we're just going to solve it. Okay, so 10 times x is 10x, right? Equals, if we put that in our calculator, 11 times 20 is 220. Okay, then we know what to do. Last thing we want to do is divide by the coefficient, so x equals 22. Okay, so that's it. Okay, so just going to use that rule. So keep it in mind. Let's go to a next level one. All right, so this one we're going to do the same thing, right? We see two intersecting chords. So first thing we're going to do is we are going to label. Right, so we would say that that's, we can think of this as part one, that's part two of this one, right? Okay, and then this is part one, and this is part two of the other one, right? So let's set it up. Okay, so let's just think of it like this, right? So part times part equals part times part, right? Now that we got that, let's fill that in. All right, so let's think about this pink one. First part is 4, second part is 3, right? 4 times 3 equals this part times this part, right? So the first part is 2, the second part is x plus 1, right? So 2 and then x plus 1. All right, so once we set it up, let's just do the math. All right, let's go from left to right. First off, 4 times 3 we know is 12, right? Equals, all right, now this we're just going to do our distributing, right? So 2 times x and then 2 times positive 1. 2 times x is written as 2x. 2 times positive 1 is positive 2. Right now it may look a lot easier, right? We're just going to solve. Right, we're going to subtract 2 over there, subtract 2 over there. Those cancel out, so I got 10 equals 2x, right? And I hope it's okay with it being over here. I know you got this. If they're both equal, we could just swap the sides if it helps, right? But that's going to be equal to 5. equals x, right? Those cancel out. So our answer on this one would be x equals 5. So we're just going to set it up. Part times part equals part times part when it's on the inside. Okay, so let's just write our rule over here. So we're going to say part, reset. We're going to say part times part equals part times part when we're talking about the inside. Okay, part times part equals part times part. All right, so let's move on to the next page. All right, once we got that down, let's talk about intersecting secants and tangents. So all of these intersect on the outside, right? So we know our rule is, if it's on the outside, we're going to say outside times the whole equals outside times the whole. Okay, let's write that down. Outside times the whole equals outside times the whole. Okay, that's our rule. Outside times the whole equals outside times the whole. All right, so let's go ahead and go for it. So the first step, we're going to highlight and label. All right, so let's go and just highlight our stuff, right? We're talking about this and this, right? All right, so on the first one, on the blue one, let's go ahead and start with our equal sign, right? So we're going to say outside times outside, the whole equals outside times the whole, right? So outside of the blue one is 18. Okay? The whole part of the blue one is not 24. The whole thing is from R to T, so it's 18 plus 24, right? 18 plus 24, right? So don't miss that. Okay, equals now on the pink one. What's the outside on the pink one? It's this right here, right? Which is 21, right? How much is the whole thing? Okay, well, they want us to find, let's look at what they want us to find. Find PQ, right? So PQ is this, and we can label that with an X, right? Because something we don't know. Well, how much is the whole thing on the pink? Is it 21? Is it X? No, it's 21 plus X, right? 21 plus X. Okay, so this is a little trickier, but we just have to recognize the outside, right? And the whole, outside and the whole. All right, so now let's go and do the math. So this whole thing, that looks like we can put that whole thing into our calculator, right? Anytime it's just numbers, we can put the whole thing into our calculator. So if we put that in, that's going to give us 756 equals, now over here we're going to do our distributing, right? So 21 times 21 gives us 441, right? Plus 21 times x gives us 21x, right? So now it may look a lot easier. We're just going to subtract that 441, subtract the 441, right? If we do that, we're going to get 315 over here, right? That cancels out, equals 21x, right? Then we know we're just going to divide by 21, divide by 21. It says round to the nearest tenth, okay, if we don't get a whole number. So let's do that. X is going to be approximately, actually, it's equal to 15, right? So it is a whole number, all right? So that's our answer. X equals 15. Okay, so all we have to do is set it up. When it's on the outside, we set up that outside times whole equals outside times whole. All right, let's keep it moving. All right, let's look at this one right over here. It says, given this circle below with secant ONM, right, and tangent LM, okay, find the length of ON. Okay, we're trying to find the length of ON. Let's go ahead and label that with an X, right? So the first step we wanted to do is we wanted to label our stuff, right? Okay, so, and then highlight as well, right? So I'm going to highlight these two different colors. That one's going to do one color, and that one's going to be another color. So let's go ahead and step number 2, let's go and set it up, right? So we said outside times the whole equals outside times the whole, right? Okay, so on the blue one, what's the outside? Outside on the blue one is 19. Okay, so we said outside times the whole equals outside times the whole. So the outside on the blue one is going to be 19, right? And the whole thing on the blue one is also 19, right? The whole thing is also 19. Equals, now let's do the pink one. What's the outside on the pink one? Is it X or is it 16? It is 16, right? That's the outside. And what's the whole thing? Is it x? No, it's x plus 16. The whole thing is x plus 16, right? All right, so now that we set it up, now we can do the math. It's quite easy. We're just going to type this into our calculator, right? 19 times 19 will give us 361. Okay, equals, now we're going to do that distributing, right? So 16 times x is going to be 16x. 16 times 16 is 256. That's a positive, right? So now we're just going to subtract that 256, subtract 256, right? So that's going to give us 105 equals 16x, right? And so then we're going to divide by 16, divide by 16. So x is approximately 6.562. It says to the nearest tenth. That means we're going to look at that 5. Ask the 6 what to do. It says that's going to raise it to 6.6 is going to be our final answer, right? All right, so that's it. On that, let's do our final one. Let's see if you can set this one up on your own. All right, so let's go. Let's see, the first step we want to do is we want to label, right? Okay, so let's do that. It says find the length of QR. So QR is right over here. We're going to say that's X, right? Let's go ahead and highlight our 2, right? Label and highlight. Okay, so let's go ahead and set it up, right? So we said outside times a whole equals outside times a whole, right? So let's set it up on the pink one. Let's start with that one. The outside is 24, right? Okay, the whole thing is not 31, right? It is 24 plus 31. 24 plus 31, right? Equals, what do we know over here? The outside on the blue one is X, right? The outside on the blue one is X. The whole thing on the blue one is also X, right? It's a little tricky, but you got that, right? The outside is X, the whole thing is X. Now let's do the math. This is all stuff that we can type into our calculator, right? So if we do that, that's going to give us 1320. Equals, now what's X times X? X times X is X squared, right? Anything times itself is itself squared, right? But we don't want X squared. We want X, right? So we need to take the square root of both sides. Square root. Take the square root is how we pronounce it of both sides. Okay, so if we do that, that means if we take the square root of that, that's going to give us X, right? And that's going to be equal to the square root of the other side, which is 1320. Right? So now if we put that into our calculator, X is going to be equal to approximately 36.333, right? But it wants the nearest tenth. So we're going to say that 3 tells us to keep that. And so we're going to say X is approximately 36.3. Okay? So I know you got this. That's the basics of it. But this is our last day of notes for this. So we're just going to keep in mind that if it's inside the circle, we're going to do part times part equals part times part. If it's outside, we're going to say outside times a whole equals outside times a whole. All right, if you have any questions, just let me know, and we'll wrap it up.